This is section 4.1, linear functions, part 2, and we'll begin with writing an equation for a linear function. To write an equation representing a linear function from a graph, so we'll be given a graph, the first thing we need to do is find the slope. And we can find the slope either from 2 points on the line or by counting the rise and the run on the graph. The second thing we'll do is find the y-intercept, b. And the third thing we'll do is we'll plug in the values in for m and b into this function f of x equals mx plus b. Now sometimes b isn't clear. So maybe if it's not exactly on one of the points on the plane that you can identify exactly, and I have one like this, let's also put a note here. Or use y minus y1 equals the slope x minus x1. And this would be if the y-intercept isn't clear. And that's the point slope form of a line. And then, of course, then we'll let y equal f of x, since we're writing functions and not just equations. So whatever you get for y above, we'll let that equal f of x. So I'll underline that. Okay, let's look at number 3. So the first thing we're going to do is find the slope. So slope is, and starting at this point here, which is b, we might as well write that down, the y-intercept. We're going to go up 1, 2, 3, and to the right 1 to get to another point that we can identify. So we're going to go up 3 to the right 1. And of course, that's equal to 3. So now let's go ahead and write f of x equals mx plus b. And now we can just fill those in. Our slope is 3 and our y-intercept is 2. Let's go ahead and look at number 4. Now this is an example where b isn't clear. Maybe I'll even write that. The y-intercept isn't clear. Somewhere between, 3 and 4, little closer, less than 3.5. So we definitely need to take a better look at this. So we'll find our slope using our slope equation. So we'll write those 2 points down, which is -4, -2, and 2, -4. And we will take our y values, -4 minus a -2, and subtract our x values. And that is -4 plus 2 over 6, which is a -2 over 6 and a -1/3. Okay? And now we can use this alternate equation when b isn't clear. So we have y minus y1 equals the slope x minus x1. Now it's really, really good that you have a point ready to go. So our point is, you can pick either one. I'm going to choose 2, -4, and our slope is -1/3. So we have y minus the y value equals the slope x minus the x value. Let's simplify. And then subtract 4 from both sides. So if you have 2/3 and you want to subtract 4, you could take 2/3 minus 12/3, which is a -10/3. So I need to get rid of that plus sign. Whoops, I think I got rid of much more than just the plus sign there. And then it's -10/3. So now we'll say f of x equals -1/3 x minus 10/3. Okay, Now, looking at 5, I want to point something out. Of course, we call this a constant function. There is no slope. It doesn't slope up. It doesn't slope down. No slope up. No slope down. The slope is 0. You might also think of these are positive slopes. These are negative slopes. And what number is between positive and negative numbers? You guessed it, 0. So you could think of it like that. But something else I want to note, if you just wrote a few coordinates down, let's just pick a few randomly. This is 4, 3. This is 1, 3. And this is negative 4, 3. So what do you notice? Y is always 3. And actually, that's the equation of this line. F of x equals 3. So it's really important, I think, to notice things like that and put words to that. That way, it's easier to identify. If you wanted to do it the other way, you could go ahead and say the slope is 0 and the y-intercept is 3. So f of x equals 0x plus 3. So f of x equals 3. You can do something like that. Okay, now this time in numbers 5, 6, and 7, we're going to be given the functions and we're going to have to graph these. So there's multiple ways we can do this. The first, we're going to plot points. Then we're either going to use the y-intercept and the slope or transformations. Most students do better with B. Use the y-intercept and the slope. So let's give that a try. The y-intercept is 6. And the slope is negative 2. So that is down 2 over to the right 1. Now you could also have up 2 to the left 1, but you have to decide one or the other. So I'm just going to put the negative in the numerator. Okay, let's do this. The slope is 2, and now we're going to go down 2 to the right 1. Down 2 to the right 1. I did not want to make a mark there. And now we have a slope of negative 2. And there is your graph of the function f of x equals negative 2x plus 6. Let's try that again. Our slope is negative 1/3, and our y-intercept is negative 4. So our slope is 1 over 3. We'll go to up 1 into the right 3, and then our y-intercept is 4. Let's get that 4 on there, and now we're going to go up 1 into the right 3, up 1 into the right 3. And as you can see, this doesn't have a very steep slope because the slope is 1/3. There you go. Let's give this last one a try. In number 7, our slope is 3. And 3 is 3 over 1. So we'll go up 3 to the right 1. And our y-intercept is negative 1. So here we go to negative 1. Whoops. And we're going to go up 3 and to the right 1. Up 3 and to the right 1. So now, and that's a pretty steep graph. So you can kind of see, I did that right. Has a slope like that. Okay, not exact, but pretty good. And that concludes section